Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. All right, guys, today we're going to close up factoring, and we're going to close it up by talking about factoring special products, and then I'm going to review all of the general factoring skills or strategies. And the special products are pretty easy, and I'm going to show you the formulas on how to solve, or rather, there's not solving, how to factor special products quickly and easily. All right? Some of these you have to memorize. Some of them you can factor them doing the long way. I will let you know which you have to memorize and which you don't. But I do suggest that you memorize all of them because it will behoove you in the long run. I promise you. Okay? So let's first start with perfect squares, guys. Perfect squares. When you have a situation where you have a squared plus 2ab plus b squared, that will factor into a plus b squared. Now, you may be saying, what is this man talking about? Well, what I'm talking about is this. Let's say I have an x squared, and let's say I have here 8x plus 16. Whenever I can recognize that there's a perfect square in the first term and a perfect square in the second term, what I'm going to do is I'm going to find the perfect square of the first term. So what's the perfect square of x squared? X. What's the perfect square of the last term? 4. What is 4 times x times 2? 8x. Is that my middle term? Then it works. They're both positive, so this will become x plus 4 squared. It's that easy. So whenever you have a perfect square in the first term and in the last term, find the square root of the first and the last term. If you take those two square roots and multiply them by 2, if that equals the middle term, then you have a perfect square. If there's a minus in the middle, it works the same way. For example, let's make it a little bit more difficult. Let's say I have 9x squared. Let's do, and over here, let's do 100. So that's going to be, so let's put here 60x. Okay, and actually, let's put this as a minus. Okay. So I have this. That's a perfect square, and that's a perfect square. What's the square root of my first term? 3x. What's the square root of my third term? 10. What's 3x times 10 times 2? 60. Does it work? So you put a minus here, and you square it. You just found your perfect square. Sir? If the minus was over here, then you do not have a perfect square. Correct. If you had minus minus, you do not have a perfect square. It has to be in this format. If it's not, it does not work, sir. Thank you. Great question, my man. Great question. All right? Does that make sense, guys? Yes. Now, as easy as this is, a lot of people want to be lazy and they don't want to do the work of doing the test. So a lot of times they don't want to go this route. The good news is you don't have to go this route. If you wanted to, perfect squares allow you to go the long way. Let's say I had x squared, let's say plus, let's say 6x plus 9. Okay? Let's say you didn't recognize that this was a perfect square. You're going to go your regular method. You go x and x. What times what is 9, but when added together is 6? Okay, you're going to go 3 and 3. Oh, you got x plus 3 and x plus 3. That's x plus 3 squared. Okay, it's going to work either way. So you don't have to do this using the formula. However, it is way easier to use the formula. Again, why is it way easier? What if I give you large numbers? For example, 25x squared, and then let's say I give you a 49 here, and then I give you plus 70x. Okay? Doing that the Cuban method would be tough. You have to go 25x, 25x, and multiply 25 times 49, and then go what times what is that product, but when added together is 70. That's hard. But if you do it the method that we're teaching with the perfect square, what's the square root of 25? 5x. What's the square root of 49? What's 7 times 5? Times 2? Does it work? It's positive, so you put a plus here, you square it, and you're done. But that only works if that's a perfect square and that's a perfect square. Does that make sense, my brothers? You promise? Okay. May I? Yes, sir.
When you do the square, the first one, the square, the last one, you always do the GCF, right?
Before you do any of this, you always check for GCF, of course. Yes, sir. Thank you, my brother. Before any type of factoring, you always do the GCF. Thank you, my man. Does that make sense, my brothers? Thank you, gentlemen. Okay. Now, number 2, difference of squares. Difference of squares, guys, unfortunately, you have to memorize. You can't use the old method for this. You have to memorize. When you have a perfect square minus another perfect square, you literally are going to factor it by doing the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. For example, x squared minus 9. The square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. You're done. Let's say I give you 4x squared minus 25. Square root of the first term plus square root of the second term times square root of the first term minus square root of the second term. That's a difference of squares. There you have, unfortunately, no choice. You have to memorize that formula. So when you have a difference of 2 perfect squares, you factor it by taking the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. Questions, comments, concerns? Awesome. Thank you, my brothers. Now, I put this one in because it does mess up a lot of people, and I don't want it to mess you guys up. It's called the sum of squares. The sum of squares, gentlemen, is prime. You cannot factor this. It's not factorable. And when I have a perfect square plus another perfect square, it's prime. It's not factorable. I cannot factor it. It is prime. It's done. That's it. It's done. It's over. Just cannot factor it. Why did I put it there? Because a lot of times people try to handle it like a difference of squares, and that's wrong. It's prime. So we move on. The last 2, difference of cubes and a sum of cubes. These you have to memorize. Okay? There's no choice here. You have to memorize. The good news is that they're almost identical formulas. And the difference of cubes and the sum of cubes works as follows. When you have a difference of cubes, it's a perfect cube minus a perfect cube. And the formula is the cube root of the first term minus the cube root of the second term times the first term squared plus the product of the first term times the second term plus the second term squared. Now, what does that mean in English? Let's say I have x cubed minus 8. This is the procedure I follow all the time. Remember, guys, I've been doing this for 20 years and I still follow this procedure. Please don't try to be a hero. Follow directions. I find my a term first, and I take the cube root of my first term, which is x cubed. So my a is x. Then I find my b term, which is the cube root of my second term, which is 2. Now I literally follow the formula. A minus b times a squared plus a times b plus b squared. And I am done. You cannot factor the trinomial that you're left with. You do not have to go any further. You are done. Notice, please, that when you have a difference of squares, this is negative, this becomes positive, this guy's always positive. Sir.
Explain that at the end where the first one becomes negative or positive.
Well, you started with a negative, right? Okay. So this is negative. You change the sign to positive, and this stays positive always.
So, if it's positive, then you change it to negative.
Correct. Just like in the sum of cubes, same formula, except this is positive, change sign to negative. This one always stays as positive. Does that make sense? I was once told a little acronym for this. It's called schisms. Okay? Square, change sign, multiply, square. Not bad, right? Square, change sign, multiply, square. Yes, sir.
That's for both difference and sum of cubes.
Both have the same exact formula. I'll give you an example now with the sum of cubes. And then we'll practice. For example, let's say I give you now, let's do a little bit more of a difficult one. Let's say I give you 64 x cubed minus, let's say, 125 y cubed. My a term is the cube root of the first term. So what's the cube root of 64x cubed? Good job. At 4x. Awesome. My b was the cube root of 125 y cubed. Excellent. 5y. Now that I have my a and my b, I simply follow the formula. A, oh, and actually I should have done this plus. Let's do a sum of cubes. A plus b times a squared, that's my S for schisms, square the first term. C for schisms, change signs. So I go from plus to minus. M for schisms, multiply the first and the second term. Multiply A and B. So that's 20xy. And then the s, the second s for schisms, square the second term. That'd be plus 25y squared. Unfortunately, guys, there's no other trick I can show you here. That's just the way it goes. I know it's not your favorite thing to do probably, but it's not difficult, is it? It is something you're going to have to learn though and memorize. So it makes sense. Promise? Sir, my brother. Anything you need. Perfect squares, yes. I don't understand what you mean by what order. Difference of squares. What about it, my brother? Oh, if you put x plus 3 times x minus 3, or if you put x minus 3 times x plus 3, does not matter because of the commutative property. You could put x minus 3 times x plus 3 or x plus 3 times x minus 3. Any other questions, gentlemen, before we start practicing? Alrighty. Thank you very much, my brothers. You had a question, my man? Okay. Okay, guys, so let's practice now. So I've got x squared plus 8x plus 16. That's a perfect square, that's x. That's a perfect square, that's 4. X times 4 times 2 is 8, it works. So that's x plus 4 squared. I'm done. It's a perfect square. Done. X squared is a perfect square. The square root of that is x. 100 is a perfect square. The square root of 100 is 10. 10 times x is 10x times 2 is 20. That works. It's a negative. So that's x minus 10 squared. I'm done. Y squared is a perfect square. 121 is a perfect square. They're being subtracted. That's a difference of squares. Thank you, my brother. So that's y square root of the first plus square root of the second times square root of the first minus square root of the second. Ding dong, the witch is gone. I'm done. That's a difference of squares. I've got a perfect square, 9y squared, minus a perfect square of 64. That's a difference of squares. So square root of the first term, 3y, plus square root of the second term, 8, times square root of the first term, 3y, minus square root of the second term, 8. Difference of squares. I'm done. Perfect. Number 6. Whoa, those are not perfect squares. But can anyone help me out here? What can I do here? Very good, son. Thank you, my brother. Very good. I can take out a GCF, though, and now I'm left with x squared minus 1, which does render a difference of squares. So now I've got 2 times x plus 1, x minus 1. Excellent. Because the square root of 1 is 1. Okay, number 10 looks a little challenging, but let's see what we got. 4y squared is a perfect square. That's 2y. 81 is a perfect square. That's 9. 2 times 9 is 18 times 2 is 36. This works. It's a perfect square, and it's positive. So this is 2y plus 9 squared. 36x squared is a perfect square. That's 6x. 25 is a perfect square. That's 5. 6 times 5 is 30. Times 2 is 60. That works, and it's negative. So this is 6x minus 5 squared. 4x is a perfect square plus 81, which is a perfect square. But that's a sum of squares. That is not factorable. That's prime. 27x squared is not perfect square. Minus 12, that's not a perfect square either. Can I do anything here to try to help me out, though? Good, GCF. What's the GCF here, gentlemen? So let's factor out a 3. Let's see if that helps us. I've got 9x squared now minus 4. Now I've got a difference of squares. So this is 3 times square root of the first plus square root of the second times square root of the first minus square root of the second. Excellent. Excellent. Now, we got some difference of cubes. So let's get my A term. Cube root of 8y cubed is 2y. My B term is the cube root of 27, which is 3. So I've got my A minus B times A squared, change the sign, plus AB, very good, 6y, plus B squared, which is 9. Done. Number 8, I've got x cubed plus 64. These are both two perfect cubes. My A term is the cube root of x cubed, which is x. My B term is the cube root of 64, which is 4. So A plus B times A squared, change the sign, minus A times B plus B squared, which is 16. For 12, what do you think I would do here first? What's the GCF here though? Don't overthink it, guys. -1, thank you. So you take out a -1 here, you've got 125x cubed plus 729. Yes, someone said that 729 was the GCF. No. No. Thank you for trying, but no. 729 is not the GCF. Now we're going to find the A term, which is the cube root of 125x cubed, which is 5x, and B, the cube root of 729. Now, that one may not be as easy as one would think, but if you think about it, it's not that bad. It's 9 times 81. And you break down 81 into 9 times 9. Well, a 9, a 9, and a 9 comes out as a 9. So that's my cube root of 729. So I have my A and my B. So I have A plus B with a -1 out here because I need my GCF times A squared. Excellent. Change the sign, minus A times B plus B squared. I know that it's going to take a little bit of time for you to memorize those formulas, but you got to admit, it's not difficult. And once you memorize them, it's like butter. It's just easy. You just flow right through it, gentlemen. Does that make sense, guys? Promise? Okay. Then let me go over the last part of today's lesson, which is just a brief overview of general strategies for factoring overall. So factoring strategies. Number 1, no matter what, guys, factor out the GCF if possible. Number 2, if you have two terms, you're either dealing with a difference of squares or a sum of squares, or a difference of cubes or a sum of cubes. Those are your only choices. If you're dealing with 3 terms, you're dealing with a trinomial, you got to factor a trinomial. You're either dealing with the regular trinomial where A is 1, or a trinomial where A is something other than 1, and we go with our Cuban method. And then if you have 4 terms, you factor by grouping. And that's it. You have all the skills that you need. So let's just take a little gander at what we would do here. So for number 1, right off the bat, everything's even. So me personally, I'm going to factor out a 2 right off the bat, giving me x squared minus 2x minus 24. then I'm going to ask myself, what times what is negative 24? But when added together is negative 2. And that's going to be negative 6 and positive 4. I'm done. That's it. That's the power of factoring. Number 2. Hey, that's a perfect square. That's a perfect square. They're being subtracted. Well, heck fire. That's a difference of squares. So square root of the first plus square root of the second times square root of the first minus square root of the second. Awesome. Make sense?
Yes.
Number 3, I got 4 terms. Before I do anything, though, if I look at this, looks like I can take out a GCF. I can take out a GCF of 2. So I'm going to be left with 2x cubed minus 3x squared minus 18x plus 27. Now I've got 4 terms, so I'm going to go ahead and group them. Out of here I can take out an x squared, and I'll be left with 2x minus 3. What do I got to take out of here to make it a 2x minus 3? No, I got to take out a, no, not a positive 9, but a negative 9 to give me a 2x minus 3. Now this is a pretty cool one. Now I can factor out a 2x minus 3, correct? So I have 2 times 2x minus 3 times an x squared minus 9. Is everyone with me there? However, what do you notice? Does anyone notice anything here, guys? There's a difference of squares. Very good. So this is 2 times 2x minus 3 times x plus 3, x minus 3. Very good. Very good. And last but not least, whenever I have a negative here in the front, I like to factor that out. And if you look at all the terms, what else can I factor out of every single term here? What else? I can factor out a negative 4x. When I do so, I'm left with y squared minus y minus 3. Would I be able to factor that? What times what is negative 3, but when added together is negative 1? Positive 1 times negative 2. Good try, thank you. But it doesn't give me negative 3, sir. That's my answer. I cannot go any further. I am done. Does that make sense, gentlemen?
Absolutely, sir. Yes, sir.
Thank you very much, my brothers. Homework is valid. Hope you learned a lot, and have a wonderful day. God bless you. Bye-bye.